Hello everyone, welcome to Ansarkari. In this video, we'll be starting with the concept number 17. This is under the series of permutations and combinations. The total number of combinations of n different things taken any number of them at a single time is given by this formula, that is 2 raised to the power n. Now what this basically means is, for an example, we can take 4 objects, that is A, B, C and D. So we have 4 objects, so n will be equal to 4. Now combinations is the ways of selecting. So if out of these 4 objects we need to select any number of objects, we can select even one object. To select one object we'll have 4 options, right? Either we can select A, B, C or D. To select suppose 3 objects, we can have first option can be selecting B, C and D. The second one can be selecting A, B and C. So these are the ways of selecting any number of objects out of the given number of n objects. So its formula will be 2 raised to the power n. Now this concept number 18 that follows is, out of n different things, at least one or more can be chosen in 2 raised to the power n minus 1 ways. But when the condition says that we need to select at least one or more, so for that we'll use this formula, that is 2 raised to the power n minus 1 ways. Because this one that we are subtracting here, this one particular way is the way in which none of the objects is selected out of these total number of ways. That is the reason for this formula. Now dealing with this question number 13, there are 6 questions in a question paper. In how many ways can a student solve one or more questions? So in this case, the total number of questions that we have is 6. Now it says, in how many ways can a student solve one or more? So here the condition is one or more. It doesn't say that the student cannot solve, that the student has an option of not solving any of the questions. It does not say this thing. So we need to focus on this fact that it has to include this thing, that one or more questions. So we'll follow this case here. So the formula is 2n minus 1. So it will be 2 raised to the power 6 minus 1, and this will give us the answer to this question. Now moving on to question number 14. Given 5 different green dice, 4 different blue dice and 3 different red dice. Find the number of ways of choosing at least one green and one blue die. So here in this, what happens is, different things. We also need to focus on this thing, that all these n objects, they need to be different. None of them can be same or identical. This is also one thing that we need to focus upon, because there can be similar questions which include identical objects. So we need to focus on every detail. Now given 5 different green dice and 4 different blue dice. So 5 dice we have which are of green color, 4 are of blue and 3 are of red color. We need to find the number of ways of choosing at least one green and at least one blue die. So while we need to select any of these, whatever the number be, so the formula will remain similar to this thing, that is 2 raised to the power n. But what they say is, the condition is that there should be at least one green and at least one blue die. Red अगर एक भी ना हो तो चलेगा. So first we'll find out the number of ways of selecting green dice. So it will be 2 raised to the power 5. Now since it says at least one green, so again we need to subtract 1 here. So this is for the green dice. Then second we'll go with blue dice. So it will be 2 raised to the power 4. Again it says the blue dice should be included, at least one blue die should be included. So we'll again subtract 1. This 1 is for the case where we'll choose no blue die, which is included in this, so we need to subtract it, so that that case or that way of selection is not involved. Then for third, we have 2 raised to the power 3. Here we do not need to subtract 1, because they have given the option of not selecting any red die. Now after solving these, we'll get like 31, this will be 15, and this will be equal to 8. Now we need to multiply these three. Now why multiply? Because AND का case है, right? We have to select like the number of ways of selecting green dice. कितने भी करें उससे आ रहा है कि 31 ways है कि हम नंबर के अकॉर्डिंग देखें सिलेक्शन को. Then this is the case for blue and this is the case for red. So ये भी हो सकता है कि हम तीनों ले एक टाइम पर, right? And we have to. This is what the question demands. That is the reason why we are multiplying these and not adding. Because adding is the case for or. कि या तो हम कि ऐसे काम चल सकता है कि हम सिर्फ green dyes ले लें blue और red ना लें. So it will be okay. That would happen if that were the case, then we would use plus. But here the case is that all three of them are supposed to be included. That is the reason why we choose this. And the number of ways तो हमने इनसे निकाल लिया है, so we'll multiply all these and we'll get the final answer as 3720. So this will be the answer to this question. The number of ways in which m plus n different things or objects can be divided into two unequal groups containing m and n things is this. So now what we have to do is, suppose we have x number of objects and x is equal to m plus n. So what happens is we have x number of objects. Suppose we have 5 objects and m we can take as 3 and n we can take as 2. And we need to divide these 5 objects into two unequal groups. So unequal groups means groups of objects itself, right? So like one group can have 3 objects and the another group can have 2 objects. So the ways of doing it is given by this formula. And the reason for this is, suppose we have 7 objects with us and out of these 7 we need to create groups of like 2 and then 5 if we need to do this. So what we'll do is, first we'll have 7 options, right, to create the group. So it will be 7C, and for the first group we need 2. So we'll write 7C2. Then for the second group, how many options do we have? Now we have already selected 2, so we'll have 5 options. And how many do we need? Again we need 5, so we'll write 5 here. So after solving, it will be like 10 factorial, then 2 factorial into 5 factorial, into, if we write the multiplication sign, then again 5 factorial, then 0 factorial into 5 factorial. This will be for this. So if we solve it, what we get is again this thing, 7 factorial divided by 2 factorial and 5 factorial. This case can also be, now this was the case for dividing into two unequal groups. The case could have been when we need to divide into 3 unequal groups. So again, if we take example and solve this particular way, in the end what we get is this. So we'll simply use this formula, and in case of division into 3 unequal groups, then we'll write m plus n plus p whole factorial, and below we'll write again m factorial into n factorial into p factorial. This will be the case when we need to divide a particular number of things into 3 unequal groups. Now mind, these groups are unequal and also the objects are different. This is the case of different objects being divided into 2 unequal groups, not among anyone, right? So we'll take up this question now. In how many ways can 15 different things can be divided into 3 groups containing 7, 5 and 3 things? So again the same formula will directly apply. Now m plus n plus p will be equal to 15 if we sum them up. So it will be 15 factorial, and obviously 7 factorial into 5 factorial into 3 factorial. And after solving we'll get our answer, which after solving we'll get is 360. Now the concept number 20 is pretty similar. The number of ways of distributing m plus n things among two persons. Now here what we need to do is we need to distribute these m plus n things among two persons and not just into two random groups, right? Two or three or more than that. In unequal groups, again the same case, unequal groups containing m and n things is this. So here the difference is just this, that we need to multiply by 2 factorial. Why 2 factorial? Because we have 2 persons. If we were to have 3 persons, then we'll write here 3 factorial apart from this whole thing, which is essential. And we are using 2 factorial here because the cases will be different for every person, right? Suppose the first person gets 6 things and the second person gets 4 things out of the 10 total things. And this also can happen that the first person can get 4 things and the second one 6. So to involve these kind of combinations, we'll write here 2 factorial. In how many ways can 10 different marbles be divided between two children so that one of them may get 7 marbles and the other 3? Now here again we are dividing between two children, which is example of this previous.